Hello and welcome to Dividing Polynomials. This is going to be part one of a kind of a two-part series, I guess, because dividing polynomials can be done two different ways. And you'll gravitate towards one way or the other, depending on which way you prefer. And you'll need uh, this technique in Math 20, whether it's dash 1 or dash 2, or math 30, whether it's dash 1 or dash 2. And so this little video here is kind of designed to give you a head start on looking at dividing polynomials. And so this part will look at long division, and the second part will look at synthetic division. So we're going to start off by recalling from exponents that things like this, where we had a fraction and we had x to the 12 over x to the 3, okay, we can rewrite this expression like this as x12 minus 3. Zoom in a little bit. And we know that 12 minus 3 equals 9. So x12 over x3 equals x to the 9. Okay, but the cool thing is that you can also use your knowledge of common bases here when adding fractions to do the following. And so we have an example here of 15x cubed minus 10x squared plus 5x all over 5x. Okay, we can rewrite this complicated looking fraction as 15x cubed over 5x minus 10x squared over 5x plus 5x over 5x. Okay, and if we use the same techniques that we have from previous years, we can reduce 15 over 5 to 3 over 1. Okay, we can reduce x cubed over x using the same technique we used up here to go 3 minus 1. Okay, and then we can move across and go 10 and 5 reduced to 2. Okay, and then 2 minus the implied 1 gives me a single x. And then 5x over 5x is simply 1. Okay, and you'll notice that I mentioned that it was 3 over 1 and 2 over 1. You don't need to write the over 1. They're implied. It's kind of redundant to say that because the only time I'll ever write over 1 is because my next step will be something like multiplying fractions together or working with some sort of simplification with fractions. Okay? But this method kind of is slow, okay, and hard to work with if the denominator is a binomial or more. Okay, and so the example up here does work because there's a single term here as the denominator. Okay, but if the denominator gets any more complicated, so it has 2 terms, 3 terms, whatever, this kind of technique of pulling it apart falls apart. And we don't really kind of stop here in math. We kind of build on this. There is things we need to do in 20 and 30 that kind of use this technique here. Okay. So, yeah. Okay. And so we need to know how to handle those situations where we do have a binomial in the denominator. And so the great thing about this is that you actually already have exposure to a technique in some elementary grade with some amazing elementary teacher where they got to show, they were able to show you long division. Okay, and so we're going to use that same technique of long division, but with polynomials. Okay, so the first example we're looking at is this one here of 3x cubed minus x squared plus 2x over 4, plus 4 all over x plus 4. Okay, so this technique or this setup here, you wouldn't want to do what you did in the previous example of kind of piecing it apart into 4 little fractions, because your denominator is an expression and you can't really, it's extremely hard to reduce an expression unless you pull out common factors and you do a lot of things ahead of time. Okay, So let's use long division, and I'll show you that you can actually use this technique to divide this polynomial by this binomial here. Okay, so our first step is the setup. Okay, and so I would draw this hook here. I would draw and then write the numerator underneath the bar. Okay, and then the denominator gets written out here. Okay, so no change, I'm just transcribing. Okay, once I've done that, oh, and before we go into step 2, make sure to, when you write both this, the denominator here and the numerator here, make sure that both of them are in descending order. If they're not in descending order, I'd be very surprised if you actually get the right answer. It'll be very chaotic, and I don't think it'll work out nicely. So make sure they're in descending order, and then this technique kind of just flows from left to right. Okay? All right. So our second step, once we have this nice setup going in black here, is to divide the highest degree variable. So in this case, we're dividing the x cubed, right, or the 3x cubed, by the highest degree in the binomial, so x. Okay, now that's the official way of saying it. The way I kind of say it if I were in class would be to say, what do I need to multiply x by to turn it into 3x squared? And oftentimes when I say it like that, students are like, oh, I know. Okay, and they'll often see that, well, in order to get x to turn into x cubed, okay, I need x squared, so x times x squared gives you x cubed. Okay, and then if I take that idea and go one step further and go, well, if I had 3x squared, I would actually turn this x into 3x cubed. Okay, but I can't just transform just this one term. Whatever I do to one term in this binomial, I have to do the other term. So if I'm going to multiply this first x by 3x squared, this 4 in turn will actually be transformed, or it will be transformed by 3x squared as well. And so when I write that 3x squared down, I don't write it above the 3x cubed. I write it above the x squared term here. Okay? So 3x squared. Okay? And then once I figured that out, I go 3x squared times x is 3x cubed. Okay, 3x squared times 4 is 12x squared. Okay, and now we move on to step 3. So step 3 is subtract the result from the original 3x squared minus x squared. So always subtract. Okay, because that's what you did when you first learned long division. Don't try to mess around with the operator. Okay, you should always subtract. Now what I like to do is when I'm doing this subtraction, I indicate that sign, is I like to put this one in a bracket. Okay, and I like to do that simply because I don't want to accidentally look at this negative and go, oh, okay, well the first term here is actually negative 3x cubed plus 12x squared. Okay, I'm using this notation to tell me that this negative applies to both. Okay, so I'm going to go 3x cubed minus 3x cubed. Well, that's an exciting 0. And then I go minus x squared minus 12x squared. So they become negative 13x squared. Okay. And then once I get down to that step, okay, I do my last step here. Okay, in the sequence, I bring down, in this case, the plus 2x and kind of repeat steps 2 to 4. Okay, so I'm going to bring down the positive 2x squared, or sorry, the positive 2x. And then I'm going to repeat the steps. And so I look at negative 13x squared, and I look at the x, and I go, what do I need to multiply the x by to turn it into negative 13x squared? And I'm hoping that you can see that I have to multiply it by negative, because it's already negative. I have to multiply it by 13. And in order to go from x to the power of 1 to x squared, I have to multiply it by at least an x. Okay, and so this times this will give me negative 13x squared. Negative 13x here times 4 is negative 52x. Okay, and then again I'm going to subtract. Okay, so these will cancel out because this is a negative minus a negative, so this is a plus, so they'll cancel out. Over here I have positive 2x minus negative 52, so the two negatives become a positive, so essentially it's 2 plus 52, okay? I get 54x, okay? All right, let's bring down the 4, or the positive 4, and let's continue. So what do I need to multiply x by to turn it into 54x? Hopefully you can see that you should multiply it by 54. So that'll be 54x. And then 4 times 54 is 216. Okay, I'm going to subtract. So this and this will cancel out. This minus 216 gives you a remainder of negative 212. Okay, and so that remainder is part of the final equation. Okay, we can't just ignore it. Okay, and so when we write out our answers now, we write out using the answer we got up here, the remainder here, and what we divided the original polynomial by will actually be included as well. Okay, and so we'll move this down. We write out our answer. So bracket 3x squared minus 13x plus 54, close bracket. Okay. Probably actually don't need a bracket in there, but it is good to put it in there, okay? And then we're going to put it in our remainder. Oops, so it's a minus, not a plus. Okay, but if we were to leave the equation like this, we wouldn't actually be correct. Your equation would end up being too high or too low. So when we put in what we divided the polynomial by as the denominator, we actually end up getting exactly what we need, okay? And so that answer there, okay, of 3x squared, actually I'll write it again without the bracket because I realize I don't actually need it. So 3x squared, okay, minus 13x plus 54 minus 212, and that just term 212 is divided by x to the 4. Okay, and so we've effectively factored it out. Okay. All right, let's look at our next question here, our next example. Excuse me. Okay, so our next example here is 6x to the power 4 plus 4x cubed minus 10x plus 2. All of this is divided by 2x squared plus 4. Okay, and so when you start off something like this, there will be someone out there that will try to just go straight to setting up. And if you do that, you might actually get the right answer, but you might go in a direction that is more complicated and harder to work with. And so whenever we have a polynomial question, whether it's a simple one or something harder, let's try pulling out common factors first, right? You should see that the numerator has 4 coefficients here. They all happen to be even. And if we look at the bottom here, they have 2 coefficients. They all happen to be even. Okay. So if we pull out a factor of 2 out of the numerator, we get a 2 out front, open bracket, 3x to the power 4, plus 2x cubed minus 5x plus 1. I'm going to do the same thing for the denominator. Pull out a 2, giving me 2 open bracket x squared plus 4 close bracket. Now that I've done that, these cancel out, giving me something that is equivalent but simpler to work with, smaller numbers. Okay, and now that I have those smaller numbers, I can move on to the same step 1 as we did in the last example. Now the setup has this up and over, okay, and we start writing it out here. So 3x to the 4 plus 2x cubed. Now, in this situation, because there is no x squared, you want to kind of have a placeholder for that x squared just to keep everything kind of organized. So I'm going to go plus 0 x squared minus 5x plus 1. Okay, and now I'm ready to go. And so I'm going to do the same step 2, step 3, step 4 by going 3x to the power 4 divided by x squared, or what can x squared be multiplied by to turn it into 3x to the power 4. And hopefully you can see that if you multiplied x squared by by 3x to the power of 4, 3x to the power of 2, we would get 3x to the power of 4. Okay, and so when we want to write that 3x squared on the top here, to keep everything organized, I'm going to write it actually way up here. Okay, and then I'm going to grab my green pen here and just extend the line a little bit. Okay, and so when I do this, I go 3x squared times, I go x squared times 3x squared. I get 3x to the power of 4. And then 3x squared times 2, I get 6x squared. Okay, and notice how I left a gap here. There is no way in this instance here to get any kind of x cubes. Okay, and so there's no reason to write anything here. Okay, I'm going to subtract, and so 3x to the power of 4 minus 3x to the power of 4 gives me 0. 0x squared minus 6x squared gives me negative 6x squared. Okay. All right, I'm going to go to my next step now and do the same thing. And so I have to take x squared. Okay, I have to take x squared and look here. Oh, sorry. I got to bring this down. Okay, and now I got to go, what can x squared be multiplied by to give you, oh, I got to bring this down too. Sorry, yeah, the placeholder there should have actually had a 0x cubed, and then I should have done 2x cubed minus 0x cubed. Okay, and so I bring it down. All right, so now I got to look at it and go, x squared times something gives me 2x cubed. Okay, and hopefully you can see that it is 2x. And so I'm going to write that down here. So 2x times x squared gives me 2x cubed. 2x times 2 gives me 4x. And I'm going to put a nice placeholder in here. Okay. And I'm going to subtract everything. So 2x cubed minus 2x cubed. Negative 6x squared minus 0 is negative 6x squared. Negative 5x minus 4x gives me negative 9x. And now I'm going to bring down the 1. Okay, to do it again. Okay, so x squared times something will give me negative 6x squared. Okay, and hopefully you know that, or you can see that that's just simply x squared times negative 6. Okay, so it gives me, oops, sorry about that. So it gives me x squared times negative 6 gives me negative 6x squared. Okay, and then 2 times negative 6 is negative 12. And then I just have a placeholder in here. Okay, I'm going to subtract everything. Okay, and so negative 6x squared minus negative 6x squared. So this will become a positive. Negative plus a positive cancels out. Okay, the negative 9 is still there. And then 1 minus negative 12. So 1 plus 12 will give me plus 13. Okay, and that actually becomes my remainder. Okay, and so now when I write out my answer, I can write out this up here, okay, and then plus this over this. Okay, so therefore 3x squared plus 2x minus 6. Okay. Then I'm going to write it like this. And I will rewrite it to bring out the negative in a second here. Okay, so you might write it like this. Some other people might write it with the negative factored out. Okay, and so either version is fine. Okay, all I did to go from this version here to this version here is in the numerator I factored out a negative 1, and that's what kind of pops out front here. And then when I do it to each term and I factor out the negative 1 of the second term, instead of it being a plus 13, it becomes a minus 13. Okay, and so this one is a pretty challenging one for grade 10. It actually might even be a challenging one a little bit for grade 11, but if you can kind of follow along and understand why I'm putting these placeholders in here, putting them in all the time, the question really doesn't become that complicated. Okay, knowing that you need to put placeholders in takes it from a typical division question to a challenging division question. Okay, all right. There are some questions in the textbook. In the workbook. Let's see. Okay, so on page, if I'm looking at the 2006 workbook or the workbook that's available in the course here, on page 26, 27, 28, and 29, there is a series of division questions doing something like question 1AC, question 4, ABC, and then question 6 would be a good one. Just noting that when you're starting with something that is like a division sign, the classic division sign, okay, so that one is just like that, right? You can rewrite this as t cubed plus 6t over t minus 3. Okay, and that's what my first step would probably be, just so that I can move forward with the same process that I've used in the examples here. Okay. All right, any questions, send them to me.